We are solving ISS 2022 paper 3 question number 2a. So in the first part it is a basically a derivation type question, so skip this. So the second is, so under the standard notation it is given, okay, so we have given the following values and we need to estimate the population mean using ratio estimator, okay, so and find its variance. Okay, so the formula for the ratio estimator is given like this, and in terms of the question, so capital Y bar cap and X bar cap here denoting the sample mean of Y and X respectively, and capital X bar is denoting the population mean of auxiliary information, which is X. So just replace here Y bar with this according to the question, so and put the values of Y bar, X bar cap and X bar here, so you will be getting 5000 as your ratio estimator. So we have done this part, estimate the population mean of the ratio estimator. So we have done this. Now we need to find the variance. So if you look at the book and and the sum note, then the formula for the MSE is given, not for the variance. Okay, so but MSE and we need to find the estimate of the variance. Okay, we need to find the estimate of this. So MSE and variance are related with this formula. Okay, and when MSE and variance will be equal, so MSE and variance will be equal when YS is 0 or it is negligible. If it is negligible, then they are approximately equal. So there is a condition that we can check if bias is negligible or not. So recall this. So if you see the chapter 5 of sum notes of sampling theory, then it is given that so in the proof of this, okay, so if coefficient of variance of X bar is less than 0.1, then bias of R cap may be safely regarded negligible in relation to the standard error of R cap. So it is saying that if coefficient of variance of X bar is less than 0.1, then we can neglect the bias. Okay, so let's check this, because if it is negligible, then they will be equal. So let's check this coefficient of variance of X bar. So it will be equal to standard deviation of this divided by mean. Then further this can be standard error of X bar is basically square root of this variance, and this further we can write using the SRS WR formula like this, and we have given all these values in the question. If you put the values, okay, and find the value of coefficient of variance of X bar, then it will be like 0.0078, and it is less than 0.1. So according to this condition, we can neglect the bias bar. Okay, so it is very small, so we can this means MSE of IR cap and variance will be equal. Now variance and MSE will be equal, so their estimate will also be equal. Okay, cap means here the estimate. Now the formula for MSE is given in your notes. Okay, so you can see that. So this is the formula for the MSE of the ratio estimator, estimate of the MSE of the ratio estimator. Okay, so we are also given the value of rho here. Okay, so there is no rho here, so how? So rho is related with Sx by and Sx by S like this. So Sx by is basically rho cap into Sx into S by. So replace here. Okay, now all these values I have given to you, just need to put the values. So what is f? F is basically 1 minus n by n, and this, if you put the values, just put the values of f here. Okay, and what is R cap? R cap is Y bar divided by X bar, small y bar divided by X bar, and it is in the question notation, and if you put the values, then we will get R cap as 100. Okay, so this is 100, Sx square is given to you 2 into rho, so it is basically rho, and this is Sx and this is Sy. Now if you further solve it, then you will be getting variance of Y bar, variance estimate of the variance of the ratio estimator as 1552.57. Okay, so it may happen that there is a calculation mistake, so or if there is a conceptual mistake, then please let me know in the comment section. So